a lot for having us today. So we are two persons from Software Edge today. Myself, Roberto I will introduce myself in a few seconds, and Morane Grumpeter. I wonder, Morane, if maybe you can turn off the camera a second for people to see you. Okay. And Morane is head of Open Science Operation at Software Edge with us. So I will take you through a very short introductory tour on what we try to do as Software Heritage, in particular for something which is related to open source in general, which is, I think, the interesting part for you since you're running OSPOs in university. But please feel free then to ask any other question you may have. This is just a selection of the different points. So as a part of a short introduction about myself and a short period let you understand from what standpoint I'm speaking. I'm basically a computer science professor in Paris. I have been doing teaching, education, research for more than 35 years, which means I'm getting a little bit old. A quarter of a century doing everything I can to help open source, developing, advocacy, funding, etc. And then getting older, I started to create and try to direct a direct organization or initiative for the common good. So for the talk today, what may be relevant for you is everything I did for open source in the past in France, funding and projects in research, helping the French government funding project for research, the creation of the IREAL research organization on free software, different kind of challenges there. Of course, software heritage, which is the main topic of today, but I'm also part of the National Committee for Open Science in France, where I lead the software college in there. Well, that was the short introduction about myself. Now, what is software heritage? We are here to see a little bit of what we can do using software heritage. This is an initiative that has been unveiled in 2016. Actually, we started working on this some couple of years before. The clear mission from the beginning has been to actually set up on a mission to collect, preserve, and make easily available all the source code that is publicly available on the planet. This for different reasons. One is preserving the cultural heritage, which is embedded in the software. The other is actually to look forward, analyze what happens, and enable better science, better software for all. In a nutshell, this boils down to actually building something that you can consider a reference catalog for software that is out there, because there is a lot of software available publicly and a lot of open source out there, but on so many different places. Of course, the biggest fish in the pond is GitHub today, but there are many other platforms and package manager, distribution, etc. And so we are building a structure where you can find everything, not just what is on a particular platform. The second point is actually building an archive, because digital commons are actually more fragile than what one thinks. Of course, anybody can create and remove a project. This is normal life, but we have seen big platforms disappearing. Gitorius, Google Code, a part of Bitbucket in the past, endangering millions of projects at once. So we need a place where these projects are actually preserved. And last but not least, we try to build an initial layer for research infrastructure that allows us to massively analyze the source code on which all of our modern society is based today. As a short anecdote, one of my best friends is an astrophysicist. He was mission head on JWST, and I have always been super admirative of how the astrophysics community has managed to get together and fund incredible projects like this telescope that costed $10 billion and required 30 years of work. And I was so disappointed that in computer science, in IT technology, we are not able to do the same and build this very large telescope to explore the galaxy of software development. But we try to actually contribute there and bring together more people that will help going into that direction. Well, how is this designed? So we design software as a kind of a universal software archive, a shared infrastructure that it means on one side, we copy the Unix philosophy. Okay, so do one thing, do it well, and make sure you can interface with the rest of the tools properly. And then the other point is we really try to be generic, so do as many things that are relevant to all kinds of things. Why I'm insisting on this, because I feel, if you let me a couple of minutes to specify this, that in everything related, for example, to open access in science, it was another very, very important subject for us in research. I got involved in the discussion when I was younger, and there I think we failed for a bunch of reasons to take advantage of the IT technology for doing open access. And part of the story is also that we didn't see back then that archiving and making available publication did not depend on the field. Okay, you can build an open access archive. It must not be specific to physics or mathematics. It is general infrastructure. So we build an infrastructure which is not just for research software. It is not just for industry software, not just for French software, not just for US projects. All software of the planet. And we want to build one infrastructure, but it is open and shared with the others. Today, after almost 10 years of work, we have built the largest archive of software ever, or even these numbers are not up to date. This is growing every day. So there are 320 million projects, more or less, archived, over 20 billion unique source code files. And this is collected automatically, or semi-automatically, we will go back to this, from many, many, many different platforms, more than 2,000 platforms. But here you have a sample of the biggest one. GitHub, GitLab, GitLab.com, and then many, 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 many GitLab instances you can find around, but also distribution like Debian, package manager, like NPM or Maven, you name it. How you can build something like this? We could have created a for-profit operation to, I do not know, build profiles of developers selling it for corporation for a price. But no, the idea from the beginning was to build an international non-profit initiative, trying to design as much as possible for it to become long-term, or until the next nuclear war, you see. And so for this, we need people sharing the vision. For this reason, 2017, we had an agreement with UNESCO, between INRIA, which is our host institution, and UNESCO on long-term software preservation. And so you have many people supporting. You can see the logo. This is a selection. On the left, you can see a bunch of supporters. And of course, this costs money. Building an archive is not for free. And so over time, we have brought together a certain number of supporter, members, sponsors, donors, depending on their different roles, where you can see here the logos. There are research organizations, large company, corporations, many medium, small organizations, public bodies, etc. And I take this occasion also to thank the Sloan Foundation that helped us doing some cascading grants that improved the infrastructure a few years ago. How does this work under the hood? So basically, if you know the Internet Archive, there is people crawling the web to collecting web pages. Imagine software as a kind of an Internet Archive for code. It is only more complex because there is no standard for listing the project out there. So we needed to build adapters to talk with GitHub, with GitLab, with Bitbucket, with Git, with all the distribution, etc., etc. So we have tens and tens of different adapters that have, as a result of listing the public code that is available on one of these platforms. But we do not stop there, because once you list the code, you discover it is maintained using so many different things. People use Git today, but there is a lot of software that is maintained or has been developed using Subversion, Mercurial, other things. Package managers are all different. So we decided to go the extra mile and actually extract all the development information from these different version control system package formats and rebuild all the history of software into one single, unique, gigantic, deduplicated graph. Technically a Merkle graph. There are hashes all over the places. And this let you have all the global development history, which is permanently archived in a uniform, simple data model. The idea is that if you come back and try to reread the history in 10 years, imagine the Git is no longer the prominent version control system, or imagine today you are using CBS or the subversion tools. Instead of scrambling to find the right version of the tool, you have a simple data structure where you can recover all the information. Actually, this was the only sensible way of building a long-term archive, if you think about it technically. And so this graph, today to give you some numbers, it is 50 billion nodes, 700 billion edges and counting, and all the file contents occupy more or less 2 petabytes of data from the moment. All I was saying, I mean, this is a spatial graph. So the identifiers of the node are actually computed from the cryptographic hashes of their content or of the nodes they depend upon. So these identifiers, which are called the software hash persistent identifiers, or SWHID, or SWID, as I use to say. Now we have this identifier for 50 billion items, all the nodes which are intrinsically there. They are very simple to understand. You know, there is a simple prefix here. This is a software hash identifier, a schema version, because the algorithm for the hash may change over time. This is version 1. A tag that tells you what kind of object you are identifying, and then the hash that has been computing out of it. What kind of objects can you identify in the archive? The content of a file, a directory, a revision, a release, a snapshot. These are the different things you can have. And these identifiers are intrinsic, that is to say they are computed from the content itself. It means that if somebody has a copy of the same content, they compute the same identifier, following the same algorithm, they will get the same exact result. Nothing new under the sun for software development, because this is how we are building distributed software in a distributed way using distributed version control system like Git or Mercurial or Bazaar, etc. But we also added some extra qualifiers that allow to tell you, this node in the graph, this particular directory, actually, I can add some extra information here, like the place where I got this software in the first place, this origin. What was the status of the repository when I visited it in the visit I'm looking at? What is the name of the file and the path of the file? Where in the root directory of the revision that is for me the anchor in the graph starting from which I compute the path? And if I want, I can go down to the lines of code and see exactly how things are done, what the fragment of code I'm interested in. I can give you a couple of examples. I mean, for example, this one is an embedded link with a software hash ID that brings me in front of a particularly interesting fragment of the source code of the Apollo 11 that was used to land the man on the moon many years ago, thanks to Margaret Hamilton, who oversaw all this development. You see, you are exactly in front of the fragment of the code that is of interest for you in an archive that is designed for software. So you see here the code, there are different branches, releases, you can see the kind of software, different visits, you can see where it has been collected from, on what date we had the last check, etc. But so the point is that this is not a new thing under the sun, it is part of the software package data exchange specification from the Linux Foundation version 2.2. The prefix is registered with IANA. There is a property in Wikidata that is associated to these identifiers. And some 3 years ago, we embarked into the extra work of standardizing these identifiers, because we know how to compute it. There are several implementations for doing this. They are compatible with Git today. But the point is that you need a clear document saying exactly how this is computed to make sure everybody can implement by themselves. Took a lot of time, but now we are in the voting phase at ISO. So if you click here, you see the draft international standard 18,670. This is a formal specification that tells you how you can compute exactly the same identifier by yourself. So this was a general presentation of what we do. I mean, this is seen as a key infrastructure for open science today. If you look at the report, it was written as part of the architecture working group of the European Open Science Cloud back in 2020. A very long work that was coordinated by Jean-François Bramatic and myself. Where we brought together three institutional repositories, including Zenodo, three publishers and three aggregators, like OpenAir, for example, to have a universal point of view. And here, this picture is extracted from the report where they see this universal software archive as the key connection layer that allows to connect the scholarly ecosystem with other ecosystems where software is important, like industry, public administration, cultural heritage. And for example, public administration, everything which is in blue in these slides that I will share is actually linked. Forgive me, I mean, this is the old professor style, so I do not like to say things without supporting documents, so I put links everywhere. And then, so the French public administration has a catalog of public software, which is archived in software heritage. You can go there and see it. And there has been a huge amount of work done in the FERCOR CURIOSS European project in a work package which is fully directed by Morane, who is here on board, to build connectors with other platforms, to make this picture here the connection a reality. So there are connectors within VenueRDM, which is a white label version of Zenodo, AP Science, TaxTool, XSWMath. I do not know which one of these rings a bell for you, but I mean, many things. There will be a mirror built for the European Open Science Cloud, and of course, there were contributions to the standardization of the FOSS software hash identifier and the code metadata standard. Now, to make a long story short, so basically, software is a kind of a revolutionary infrastructure. Why? Because it is thought as a kind of a modern Library of Alexandria for source code, designed with the same idea, I mean, international, non-profit, long-term, open to all, but also designed to address the needs of a plurality of actors. So industry, research, culture, society, there are so many. And why is it a revolutionary? Because if you look at the way it is built, it is not a traditional archive. It is much more, because as you in the picture seen before, I mean, we do not store software in buckets with just a label on top of it. We rebuild the history in this gigantic graph. And not any graph, but a Merkle graph. So basically, this is half of a blockchain already. I mean, for integrity verification, it carries all the same advantages. It is a pillar for open science. It is now slowly getting traction for helping researchers to archive and reference their software, and it is an incredible playground for doing big code work, I mean, analysis, machine learning, whatever. After so many years working on the core infrastructure, we are at a point where we can support a few very important products, let's say. For me, a product is something that solves a problem for a user. And so now, since we are talking about OSPOs, the natural question is, what can software agent do for open source program offices? I imagine you will have all your ideas, but let me share a couple of mine. I mean, one thing is that, for example, it's important to be able to track, trace, analyze, find the software production of your institution. I mean, the pieces of code that are developed, the programs that are developed by your institution in an easy way. And here is a place where typically an example is worth 1,000 words. So let me see if I can make this work. Let me see a second here. Here is an example. Now let me go to the GitHub. Okay. On GitHub, I have a project. It happens to be a code library developed in 2012 for doing multi-core programming on a multi-core computer. And as you can see, it is developed in a traditional way. You have the version, the code, the files, etc., etc. This little green button you see here is actually a browser extension that we have developed to make it easy for people to check whether the version on GitHub is updated with respect to the one in the archive. It happens that mine is up to date. Actually, if I click on this green button here, I go to the Software Heritage Archive where I get the archived version. I mean, this is an archive but designed for software. You see, for example, here I can access this full development history. I mean, all the different version commits, etc. But for example, here, if I look at this particular revision, I can ask to see the changes, and you see these are the changes with respect to the previous version. Actually, this is a change on the BibTeX format of it. Now, imagine that a researcher, what happens today for a researcher in France? If I ask a researcher to make their software available for a report, for a career promotion, because the university want to know what is produced, for what, I mean, the evaluation committee, etc. Now, the only thing you need to know is to go on the version that is interesting for you, copy this identifier, then you connect to HAL. HAL, it is a national open access portal here in France. I need to connect, of course, otherwise it will not work. And I say, well, I want to upload a document that happens to be a piece of software. Okay. And now the system tells me, do you have by any chance a software hash ID for it? Yeah, sure, I have. And then you click on search for metadata. And what happens is that the system is actually connecting between this portal and software heritage, gets the archived version, check whether in the archived version, let me show you how this actually works, checks whether in the archived version there is a special file that is called codemeta.json. It is a JavaScript object notation, a representation and linked data of key metadata for my software that I myself add to my repository. You see it is written like this. If this file is present, it pre-fills for me everything necessary to do the submission of the form. So basically, just go here and then click on submit. Actually, I will not do it because I already submitted it. And you see the system tells me, this document is probably already there. Okay. So you can check what would happen. So if I do submit, this is sent to moderator. They check the quality of metadata, may interact with me. Once the thing goes to port, this is the final result. So you get to this web page on the National Open Access Portal. You have the name of the software, the affiliation of the authors, an abstract, information on the metadata, the license, etc., a snippet for citation. If you want to import a citation in BibTeX, for example, you can. It's pretty easy to have the BibTeX citation already there. You can go and explore the source code archive, the software heritage as you want. See, so for a researcher or a research engineer, this is a no-brainer. Okay, but you say, but he has to write the code meta thingy there. Well, okay. First, if you're an engineer, probably you prefer to write it yourself in your personal code editor. But if you don't, we also provide the code meta generator here that has been provided to the commitment project by us, in particular Morane, Valentin, and others did a lot of work to this. And there you can say, start typing things. This is a great piece of software, of course. And you see down there, all the linked data is generated for you, so you can copy it and put inside the repository if needed. But you know, the good news, do not stop here. The point is that once you do this, imagine that now, for example, in this year, a quarter of the universities here in France are undergoing a national evaluation exercise. For this national evaluation exercise, we are required to provide all the publications, all the patents, and today also all the software that has been developed over the past 4 years associated to different organizations. Now imagine that you are working for one of these universities or one of the labs, and you want all the software produced by your people. I can tell you what happens because this happened to me, okay, when I was just a researcher, etc. And you basically on a Friday night, you get an email from a desperate email from the director of the department and say, we forgot, we need to put a list of software we contributed to. Please, everybody add a line in the shared document down there, which is not very efficient. Somebody need to suffer about this. Now you can go here and forgive the lack of ergonomy of the interface. I do not know why people do this, but I mean, here is logiciel, in French is software. So I'm selecting the document type software. And for example, I'm taking the one developed in the robotics laboratory in Montpellier. And I'm asking to get all the software produced there. Let's search for it. I mean, here are the results. So you see you have all the list of these results. For example, you can look at this Limbox entity. Here it is, all the contributor, Drexel University, Raleigh University, United States, Naval Academy, etc., etc. And you can export in any kind of format that you want. In particular, what we do at INRIA, because we are doing the same exercise right now today, we are exporting all the publication and all the software produced in INRIA over the last 2 years, and it is properly structured in a large BibTeX document, and then this is used to produce a final report, which is submitted to the reviewer. Well, okay, so I was a little bit long, but I wanted to show you a real demo of what you can do in France only, unfortunately, for the moment, to see where the value is. Okay. Otherwise, you can find the link in the slides here. So, of course, you have a curation mechanism that is behind the scene. You don't see it there, but Morane could show you the interface. And then you can, of course, get an example of code. So in the slide, you click here, you can go exactly see the results. So for INRIA, if I click here, I get the list of the production from INRIA. You can select, of course, the date, etc. So if you have software heritage on one side and the mechanism for doing curation for metadata on the other side, in France we have HAL, you can address all the needs of everybody involved in this in a university or an open source program. I mean, for research and engineer, I need to make sure my software is available somewhere. I can cite it in a paper. Okay, I can get credit by proper citation. I'm not showing this, but maybe in the question we come back. Add a list of software in my CV with basically zero effort, because just once I put my code meta there, and then all the rest is automated. Okay, you can get it. And for laboratory organization, the director can sleep better on Friday night. No need to send out desperate messages to the member of the department. You just click on the button and you get everything that is funded or supported or related to your institution. I mean, and get a curated catalog. So what is the idea I had in mind? I mean, it was not just to make you jealous of French researchers. It's to say, we see, so we made a real effort to make this available to everybody. So let me get back. Available to everybody. This is the reason why we engage. Morane spent an incredible amount of time engaging in the FERCOR for CURIOSS project, other European project, to make sure there are connectors with Zenodo, with InvenioRTM, with other platform, other mechanisms, in such a way that if you already have such a platform, you could have the same benefit by connecting with software. But we have seen it is very difficult to actually have the same functionality everywhere. So we decided creating at least the minimum viable product that provides all of you with this, your own institutional portal. Okay. The idea is to monitor and showcase all the production of your institution. Curated, not random collection of things, but curated metadata, having a persistent reference, the identifier that provides you exactly the version that you want to see, providing uniform citation, and you have seen automated all this paperwork which is creating our reports, indicators, etc. And then you can ask us, I mean, I'm putting the answer there. So why building this on software heritage instead of just taking another application? Well, first of all, because in software heritage you have a completely platform agnostic way of doing things. So if your researcher use GitHub or GitLab or Bitbucket, or they put it who knows where, etc., well, it doesn't matter. the mechanism, the collection mechanism we have is compatible with all of them. And the other point is that you can share metadata with other institutions that may add metadata to the same software, and then you can compare things. And we are developing tons of new functionalities on software, so you automatically get the new functionality when it came out. And so if we want to go into that direction, I think we need your help. We really want to do that, but we do not want to reinvent the wheel or building something which does not fit with your needs. So we really would like to have everybody interested to come and lend a hand to understand what should we develop first, or the different kind of things you need. For example, for the curation workflow, should it be like what I showed to you? That is to say, the researcher put the meta files, then does a submission with the identifier, and then there is a curation there. So you're asking the researcher doing this. Or should be somebody in an institution that scouts for the software and add the metadata in software with the authority of the institution, or maybe both. And what do you want? Do you want an on-premise solution, so you run your own platform and it is just connected to the software API, or do you want us to have a software as a service for people that do not want to run it? And what kind of reports, what kind of extraction you want to see in building this kind of system, you see? So these are many questions in the design phase, and we want to have you early in, if possible, and not discover later on that there were better design decisions. I'm taking too much time, but this is the last slide. As a conclusion, I think there is a unique opportunity for what you do in the hospital, and there are so many other things, but I just try to focus on the main one. Software is already here. It is not a company. It is vendor neutral. It is non-profit. Everything we do is open source. It's designed to be worldwide, so it is not off limits for people in whatever country or whatever. It is a long-term initiative, and it is already providing functionality. So long-term archival, reference, a global reference knowledge base, and interesting and mutualization of cost. I mean, just running software, the shared infrastructure is much cheaper than build everybody a single a portal and an archive with the backup and sysadmin, it's all over the place. So the little call to action to end this and move on to the question phase is, I think it would be interesting if you can consider get involved, and to get involved, you can join the Archive and Libraries Interest Group that has been just created, and then you can contact Morane to know more, and get involved in the new application, designing this new application, because we are finally in a position where we can start to provide value on top of the archive for everybody that needs to use it. And here you will see there is the annual report 2023 and a short video that describes 5 years of the initial 5 years of software heritage that you will be able to see or download.